Yes, hello everyone. So, the next question that we are going to do is a question based on finding the minimum time taken. Okay, they'll ask you a question like this: in which path should the person move so that the time taken by the person is actually minimum? So these type of questions are pretty common. There are two ways of solving this. One is a standard way which majority of all of you would be solving, but it's a little bit lengthy method, and that method is by using the concept of differentiation. So let us look at the question first. Okay, it says that, look at the question. From point A located on a highway, one has to get by car as soon as possible to the point B located in the field at a distance of L from the highway. It is known that car moves in the field n times slower than on highway. At what distance D at what distance from D one must turn off the highway? This is the question, right? So I'm going to draw the diagram for this question. It would look like this, a simple diagram. I'm having this as the highway. Somewhere here is the point D, and somewhere here is the point B. So this is D, this is B. This distance is given to us as L. Okay, and you are having this point here as the C. A, from A we are going to C, and from C we are going to B. Okay, once again, from point A located on a highway. So A is actually on a highway. One has to get by car as soon as possible to point B located in the field. So this is field at a distance L from the highway. It is known that the car moves in the field n times slower than on the highway. At what distance from D must he turn off the highway? Okay. So this type of question you can solve in two methods. I told you. One method is we can say that, let us say this distance covered by the person on the highway, let it call it as D, small d. Okay, if that is D, and if total distance we were calling as some capital D, then the remaining distance would be D minus D, capital D minus small d. And this distance is L, the length. Now using this D minus capital D and this value L, we will be able to get a relationship for this length of BC, because this would be a right angle triangle here, 90 degree it will be. So using Pythagoras theorem, we'll be able to get the relationship of BC. Once you get that, you can find the time taken for AC. Find means you can write a relationship. You can say T1 is equal to the distance traveled here, D divided by the speed. Also T2, the time taken here is nothing but the distance traveled here. We can obtain distance traveled here by what? Obtaining the CD and the DB. This we can write the CB relationship, I said, no, using Pythagoras. But that distance divided by the velocity there, you'll get the time T2. Now total time should be minimum. So you can say T1 plus T2 is capital T, and that capital T should be minimum. So differentiate it. The variable here would be the D. Right? So using that, you'll be able to find out the time taken. That is one method. After differentiating, you'll be equating it to 0 and maxima minima concept. Other ways by using the light concept. It's like, if you allow a light to travel, then light will always choose the path which is always the shortest. That is a property of the light. So we are going to use that principle to solve this question. Okay. So instead of saying that it is a mechanics problem, let us talk about this in the form of a light problem. So light is grazing. Those of you who have studied the ray optics, they know that when the light passes through interface of two medium, that side is highway, this side is field. So that means this is the interface. When the light is passing through the interface of two medium 1 and medium 2, so that at that time the angle that it makes with the normal, that angle would be 90 degrees. So we can say the light is entering in grazing fashion. From point C, it has entered into a new medium. Here the angle, let us call it as the angle of refraction as R. You understand? So this is like a pretty good trick that we can use to solve the questions of this pattern. Okay, so light is always having a property of covering the distance in the shortest time. So we are just using that directly. So we are going to say this is incident ray, this is refracted ray, finally reaching at the point B. Can I use the law of refraction here, the Snell's law, saying that n1 sine I is equals to n2 sine R. But sine I value is 90. I is 90, but sine I is 1. So anyway, I'll be getting finally sine R equals to n1 by n2, where n1 by n2 is nothing but the ratio of refractive index. And you know, ratio of refractive index can be written as v1 by v2 also. Sorry, v2 by v1 also. Right? Now refractive index is called as C by V. So when you put it as C by V1, C by V2, CC gets cancelled, you'll be getting V2 by V1 like that. Okay, so that same concept I have used. Now, what is V2? V2 is the speed here in the field. And what is V1? V1 is the speed here. Okay, so if I say the speed in the highway is V, then the speed in the field is a lesser value, and they are calling that speed as V by N. This is the speed in the field. So by using that logic, on substituting here, I'll be getting it as sine R is equal to V2, speed in the field is V by N, divided by V1, speed in the highway, as V. So together I am getting finally the answer as 1 by N. This is the sine R. What is R? This is R. So if this is R, in the same geometry, can I say this also is R? Now, as per the question, they are interested in finding what? They're interested in finding this distance. This is what they want. At what distance from capital D should the vehicle turn into the field? So I am interested in finding this. Can I use the same concept of sine R here in this diagram? And can I say sine R is nothing but x opposite side by under root of x square plus L square, and the same sine R is also equals to 1 by N. That's it. Now just find the N value. So I can say x square times N square is equal to x square plus L square. So from here I can say x square is N square minus 1 L square. So x value is L divided by root of N square minus 1. That's it. I hope all of you have understood. It is actually a time consuming question where you will have to find out first of all the time by using the distance and velocity concept. A pretty lengthy equation you'll have to write, then you have to differentiate that. We have solved all that problem by just considering a light case. Instead of the car moving, imagine it was light. Then how would the light travel? If we understand that, it's pretty easy to solve, right? So it's a very nice trick. Make sure that you always use this whenever this type of a pattern question comes. Okay, thank you.